So would you please give a warm welcome to Kiranmai? Thank you.
Good morning, everyone. I'm Kiranmai Sanagavarapu, which David has managed to pronounce quite successfully. I lead the low-carbon solutions track with Fuller Technologies. And I see quite a few familiar faces, not only because you have worked with Fuller before, but also because we have interacted with you over the years, I guess. So nice to be back here in this space to talk about the industrial calcined clay. And that actually is the key word for today, I would say, because we are probably the only ones currently among the technology suppliers to have 2 working installations in calcined clay. And let's look at how that journey was. But before we go there, maybe let's also take a look at the broader decarbonization levers that we have. As you might all know, there are different ways you can reduce the CO2 footprint of the clinker production process. And there is no doubt we almost make the aviation industry look small with the amount of emissions that we have. One of the usual levers that we play with is the fuel substitution lever, or the alternate fuel space. I'm sure all of you have tried it at some point or the other in your cement production processes. There is also some of the long-term lever. Maybe I'll get a little bit of flack for saying this is a long-term lever, but yeah, long-term lever, which is the carbon capture and the well-known efficiency improvements in the market. However, the single largest near-term CO2 reduction lever is reduction of the clinker factor. And how do we do that? By reducing clinker in the cement mix, you have to increase something, and that is usually a supplementary cementitious material. So if supplementary cementitious materials are so lucrative, why is it that calcined clay is the current focus? It's probably because of the various drivers that are shaping the SCM markets right now. I have come up with maybe 3 major drivers that are shaping the SCM usage currently. The first one being the CO2 pressure on clinker production. I don't mean literal pressure, but the pressure of reducing the clinker production CO2 limits. And the various levers that are in this driver are, of course, the regulation. I was just talking to one of our attendees here about how regulation is playing a major role in reducing the CO2 footprint. The other one is carbon pricing. Some of the markets have figured out how to work with carbon pricing, and some of them are still figuring it out. And of course, the one also impacting this one is the corporate sustainability targets. So if you are at a plant which has high targets for reducing the CO2 footprint, then yes, that's also a pressure that the producers are having to work with. The second major lever being the declining availability of alternate traditional SCMs that we have. Of course, if you are one of those lucky ones who still have a huge bank of traditional SCMs, you're good. But there are also global regions where this is a significant decline in the availability. And when I say traditional SCMs, yes, I'm talking about fly ash and slag, as this industry has always known them. The third driver is the performance expectation. The cement process has changed, the cement mixes have changed, but unfortunately, your end customers still expect the same level of performance with these blended cements, or if you can give them even better performance compared to a typical OPC. And with all these drivers shaping the next SCM usage, so are there any roadblocks? Are there any challenges? Of course, there are a few challenges that the cement producers are working with. I could think of 4 top ones among the various challenges that the producers are working with. The first one being clay quality variability. If you are lucky that you have access to a clay deposit somewhere, that's the first step. Of course, you have clay. But do you have the right quality of clay? That's the next question. And we have also seen across the various tests that we have done with some of our customers that within a given deposit, the kaolinite content and the mineralogy vary significantly. And that also is one of the industrial experiences that we have with respect to the clay variability within a given deposit. The second one being the market acceptance and standards. One of us is leading all the time, one of us is lagging all the time. Probably market standards is one of the ones that is majorly lagging right now when it comes to blended cement markets. So that's one of the key challenge when it comes to calcined clay deployment at industrial scale. The third one being the permitting and environmental constraints. There are quite a few calcined clay installations that are working still with the age-old cement standards and the expectations of emissions based on those cement standards. And the last but not the least, calcined clay has to make its impact among other variedly available SCMs like the fly ash and slag as well. So for a calcined clay to make its mark, it has to be on par or better than traditional SCMs that you have already access to. When I say it has to be on par, I mean both in terms of availability, also the quality, and definitely the pricing. So all these key challenges are what is driving the reliable calcined clay production, and probably also stopping some of them to take that leap of faith towards calcined clay today. Is this something you're hearing for the first time? Probably not. Probably some of you have started in the industry before calcined clay has become a topic. I was probably one of the fortunate ones who has started along with the calcined clay development. So let's see how the travel was in all these years. Well, I was looking at some of our records, old records that we had, and I could see that there was about 2 decades of development that went into the calcined clay to bring it to the industrial scale that we see today. Way back in 2010, there was significant market interest with respect to calcined clay, and we got on board with that kind of an interest in the market, and we started our internal development. We also went on to build a pilot installation, which is probably decommissioned now, but there is a pilot installation that we built way back in 2013 to research on some of the calcined clay technologies and processes that we were working with at that point. For the next about 4 or 5 years, we were testing a lot of clays in that process and also doing a lot of validation of our own process development. But then we saw a dip in the market. We realized we were maybe a little too upfront and enthusiastic in developing this, but we didn't see the market for that. So we toned down the spirit. Nevertheless, again, we saw a renewed interest in 2019 for calcined clay, and we have worked on redesigning the technology to make it up to speed to what the market required at that point in time. We also went ahead and patented some of the processes that we are supplying right now with calcined clay. Between 2020 and 21, Pilot 10 is commissioned. Pilot 10 is a term that we use in our R&D laboratory in Denmark. That's the clay calcination pilot that we have commissioned. And then we also, at the same time, got some industrial orders, which is what I'll talk about in the next slides as well. So these industrial orders, during the time when we were working with our pilot, meant that there is a fast learning curve. And we went through that fast learning curve and successfully commissioned those plants in 24. In 25, we have achieved the performance guarantees. And maybe not many days ago, you also have seen one of our 2 installations be in the media for successful launch of their project. So with these 2 decades of experience that went into research, into development, and into industrial installation, what are the key levers or the lessons that we have learned? And this particular slide is something that we keep getting asked of why we have chosen flash calcination, why we have not gone with a clay kiln process. It's not because we thought that the other process was inferior in any way, but we just thought that the flash calcination is superior for the requirements that we were looking at that point in time. And what do I mean when I say that is it's not only about just heating up the material, the clay that you have. It is about heating it at the right temperatures to get the right structures that you are looking for. We have experience with heating the clay between the window of 750 to 850 degrees centigrade, where we have seen that dehydroxylation of the kaolinite content happens successfully. The process still continues, even at higher temperatures. It's not that once you reach 850, the process cuts off. But we have seen the problem of recrystallization happening if the heat continues in the system. And that's why we thought this is a good activation window that we could work with. And second comes the residence time. It's not just the temperature which plays a major role, but also about how much time this particular clay is exposed to the temperatures that it is required. And that has to be a very short and controlled window. And because of that residence time that we are working with, we are also able to preserve the amorphous reactive structure that we want out of this calcined clay. And the third one being each clay is different. Its reactivity is different, like what I've spoken about earlier as well. So the feed variability is also something that we have noticed in the industrial installations. So that is also another process condition that we work with when we are working with calcined clay. So the key message from this particular slide is that, yes, effective clay calcination or activation requires rapid heating and short residence time. And these conditions are best achieved based on our experience in suspension calcination systems. And that's what makes us choose the technology that we choose today. Moving on to another impact when it comes to the whole process system is the feed moisture of clay. We all know clay is not like the clinker raw meal that we are all aware of. It has different moisture conditions. And we notice that with significant moisture in the clay that we have to work with, of course, the fuel consumption is also taking a significant impact. It's no doubt that if you have to dry a lot more moisture than you have originally imagined, you have to use a lot more fuel. And that is also a process impact directly that is affecting your calcined clay systems. And this is our experience based on 10% hydroxylation of clay with a calcination temperature of 850 degrees centigrade, like I have mentioned in the previous slide. So now I've spoken about what factors matter. Now I've spoken about how we choose the process that we have chosen. So if you are on the edge of going into a calcined clay plant, okay, how much space do I need? Because this is not something which is a sideline system that you are adding on to a already existing clinker process. It is a significant impact in your whole planning of your layouts. So what we have seen is with an optimized plant layout for 1,200 tons per day calcined clay system, we typically reach a footprint of about 100 meters by 200 meters. And these, what you see here, it's not about the detail of what equipment goes where, but just to show you how the typical layout looks, it's the feeding system, the calcination system, and then the further downstream equipment. This is what fits within that 100 by 200 meter footprint for a calcined clay system. So now you have made sure you have the space at your site. You have made sure you have a clay deposit. But do you have the right deposit? Well, that's something we can help you with as well. We definitely recommend to test before you invest, because it's not lost on all of us that this is a significant investment that comes as CapEx for your projects. So what does test before you invest give us? First thing, we can help you with the raw material characterization. All clays might look similar, but they're not. So we'll help you with the assessment procedure, and we will characterize whether the clay that you have available is worthy of being an SCM or not. We can also help you with actually running the clay in our pilot scale system so that it can give you a window of looking at what your industrial installation could possibly look like, so that we can at least reduce the amount of guesswork that goes into these projects. Sure, it doesn't eliminate everything. We are bound to have some surprises, but this is a significant step. And we could also calcine the clay, give it back to you so that you could test it in your markets and see whether there is any acceptance. We can also do some more customized tests based on what kind of clay you have and what it requires. And this is what the pilot looks like at Dania in our R&D center in Denmark. So like I was mentioning, it's a versatile pilot, I would say. You can vary the feed rate between 25 to 100 kg per hour. It also comes with our patented color control technology. So we can show you the color that you can obtain, of course, based on the various mineralogical content that your clay has. You can obtain the color, and we could test it in the pilot and see what match of gray could you obtain. And like I said earlier, this is a proof of a large-scale installation so that we can reduce the amount of guesswork that is associated with calcined clays. I know you're all waiting for the next slide, but before I go to that particular slide, I'll also talk about one more, or actually the most important operational flexibility that we have in our system. Do you have access to a lot of fuels? Do you want them to not only use in your cement production, but also in your SCM productions? We could also help you with that, because the calciner is especially designed for fuel flexibility. Like I've written here, we've had experience with natural gas and oil. They usually provide stable operation. You could also use bituminous coal within the specified sulfur limits. You could also use waste fuels. So if you're on the alternative fuel journey, this is also another lever that you could play with so that you can maximize your alternative fuel substitution. Of course, again, there are some asterisk clauses that come with each of the fuel that you're using, but in the whole sense, the calciner is designed for a fuel flexibility. But when it comes to gray max, that's where the secret of the color control lies, no doubt about it. So gray max is essentially focusing on the product quality control. So there we are a little more strict in terms of what fuels you could use. LPG and oil, they are preferred for the color control. You could also use natural gas, but it is less effective with respect to its reduction properties. However, coal and petcoke are not usually recommended because they directly impact your product quality. So while the calciner is designed to adapt for the local fuel variability and accessibility that you have, Gray Max is designed directly to impact your final clay color and the SCM quality. So there is a lot of room to play based on what fuels you have, but these are the essential broader limits is what it is. And comes the most interesting slide, the first contract. So I was talking about the industrial installations we have, and this one was the first contract that we have signed in 21, as you can see. And yeah, it so happens that I picked from World Cement somehow. But yeah, so this was the first scale, full-scale clay calcination installation. And you could see the scope of supply that we have given in this particular project. It involves clay handling, the alternative fuel handling, the calciner system, and also the gas emissions abatement, which was a requirement specifically for that plant. And looking at the performance numbers, I'll not go into too detail about the specifics of the guarantees that we have achieved, but I would go on to say that this has definitely been a steep learning curve. And thank you to the customer as well for being with us on this very bumpy ride, but getting to the point of where we achieved all the guarantees that were required. And the second contract, it's the world's largest calcined clay installation currently, and it has a production of 1,200 tons per day. The customer is so proud of this installation that they cannot stop speaking on LinkedIn and other forums about this particular installation because they had a great market acceptance. And I'm told, I haven't traveled myself, but I'm told that today if you go into Ghana and go to a cement plant, you could buy this calcined clay right now in the market. So that's the level of market acceptance that they have. And when we look at this particular installation, yes, we have also achieved the guarantees in this case. And the array of colors you see is what we have achieved with the color control mechanism that we have, the one I was talking about previously about GrayMax. So that's the color saturation level that we have achieved in this particular installation. Mind you, the fuel and the power that we have shown here compared to the previous contract are different, but there are some clauses that we could discuss with you. The previous slide shows the complete power consumption of the whole system, and this one just shows for the fans and the dryer crusher. So did we stop there? After the success of the industrial installations, we are not someone who stops. We re-energize ourselves and reinvent different ways to work with the technologies that we have. So what is next in clay calcination? As of now, there are 2 projects that we are working with in 2 different spaces. One is a data-driven clay calcination we fondly call Detox, nothing to do with the spa. Detox is understanding the dehydroxylation kinetics of colonitic clays. We are also working with developing predictive models for clay activation. And there is also another stream where we are working with rapid reactivity testing for SCM quality control. And like one of the previous speakers fondly has expressed, this is a European-funded project. It is with the EU Horizon, and you can see the array of partners that we have on that project. The other angle of clay calcination that we are also trying to solve is the electrified clay calcination called EcoClay project, which is also a EUDP-funded project. And in that project, we are working with integration of renewable electricity in SCM production. So we want to reduce the carbon footprint of the industry and the processes, not just in simple spaces, but also in something like clay calcination, which is a developing stream of technology right now. With this, I want to conclude today saying that industrial scale clay calcination is definitely possible. We have 2 proofs to show you that. And take the leap, take the ride with us. We can show you how consistent SCM performance is possible with calcined clay plants. Because the key is in the process designing and testing, which is enabling us to do the reliable activation, like I have mentioned. And yes, we will continue the research and expand the role of calcined clay in this space. With that, thank you for the opportunity, and hope to see you again.